My name is Bo Thomas. I'm a learning program manager with the Academy. Before that, I spent over 10 years in tech support. So we're going to talk about the engine portion of this, and we're going to talk about basically the top 5 or so changes and improvements. Mainly it focuses on the turbo compound because the VGT engine, it's still there, it's still out there, but there haven't been any real significant changes alone to that engine. Some of the things like 24 volt and the variable displacement oil pump that you're going to learn about is on both. So we're talking mainly about the turbo compound engine, I'm sorry. So we're going to start off with what changed, why it changed, how it benefits the technician, the customer, and whatnot. So first and foremost, we're talking about the turbo. Turbo is fundamentally the same thing. Turbos do what turbos do. But what changed on this one? One of them was it now has a speed sensor. Turbo compound before did not have a speed sensor. It was a estimated value. So now for more precise performance and robustness, it's got a speed sensor on it. It does also have a lifting eye on it now when you want to lift it off. The bore is changed for optimum flow, for optimum boost and heat generation and whatnot. The wastegate actuator still does what it did before as far as regulating turbine speed and boost and things like warm-ups and whatnot. But the biggest thing about this, you can get to all 4 bolts. Those 2 back there that were busting your knuckles that you couldn't get to, especially when the engine was still a little bit warm, those days are over. You can get to it a lot easier. Not that it makes a difference, but because of how they redesigned it, the gases spin in the opposite direction. So the turbines are they're opposite. Doesn't make a difference, it still does what it does. The pitch of the blades and whatnot account for that, and they're optimal angles. So with that, we will move to the basically turbo compound itself. The turbo, coupled with the turbo compound, there have been some changes. Overall, the torque and economy in the 900 to 1400 RPM range has been improved. Optimal torque, optimal heat, that resulted in better performance, better fuel economy, better, less need for regens and whatnot. And the biggest thing you're going to find when you look at the entire package is there's now heat shields. So if you're looking at the passenger side of a truck with the hood open and you from a distance, you'll know it when you see heat shields covering the turbo compound unit, the turbo, and the exhaust manifolds. That was primarily to retain the heat in the EATs. Get it all into the EATs, not lose any radiant heat out in the engine compartment. Again, that much better fuel economy and performance and whatnot. The side effect benefit was, like for example, the floorboard is not as hot. Nobody ever complained about the floorboard being hot, but it has been noticed that it's cooler. The hood is lower slung, lower leaning, so the hood's staying cooler because of the heat shields and whatnot. Just one of those subtle changes that overall, with every other improvement, adds that little percentage point of fuel economy improvement, percentage point of performance. So they're all going to add up. And from there, we move to the EGR valve. So you have the EGR valve, and there was an issue where it was prone to the rivets breaking, taking out turbos and sometimes EGR coolers. Sometimes the butterfly valve itself would also let go. Well, now the EGR valve is not only a smart device, so it's on the engine subnet, it's liquid cooled. You've got liquid, coolant running through it. And so obviously for, now that it's a smart device, it's on the subnet, better performance, more robust reaction. But that is one billet piece of steel. That shaft, there's nothing to break off. There's no rivets. That entire shaft is one piece through here. So there's no more anything breaking off and letting go. So we'll move on. Really not much to talk about with the ventilation system. There have been improvements, but ultimately it still performs the same function. Worth noting that there were improvements made on efficiency. And so not a whole lot to go there. So we'll talk about the fuel filter housing next. Has anybody seen this style fuel filter housing yet? Okay, some of you have and some haven't. So different manufacturer, overall backwards compatible. So if you go to the parts counter now with an existing engine and say, I need a fuel filter housing, you're going to be handed this, most likely. Totally plug and play, but the AHI module has to match this. So it's going to come with it. And from now on, you're going to get this AHI module. They're no longer cartridges, throwaway cartridges. There's elements, inside here to replace. So yeah, if you have a customer that says, hey, we got a fleet of trucks and we've already got X filters on the shelf, they will start out to stock in these, but this is a vast improvement. We're saying now that we can go under normal conditions like 60,000 miles between fuel filter changes. Of course, a bad load of fuel can change all that, we know that. But good fuel, no issues, extended filter life. The one thing I will note, that if you look, you'll see two arrows right here. Originally, there was also corresponding arrows here. And the idea was, if you tightened it up, you knew it was right when this arrow was between these two, kind of like timing marks. But they determined that after so many changes, that creeps a little further out of scope. And next thing you know, this arrow is out. So the arrows have been done away with. Now it's just you tighten it to where you know it needs to be tightened. If you see some in the field, ignore the arrows. Even this one only has the arrows here, not on the housing. Somebody might say, well, what's the arrow for? Am I supposed to aim it at a certain place? The answer is no. This is a display model that just happens to have the arrow still left on the spin-on part. So just for y'all to know. Like I said, the rest of that, plug and play, that's what you're going to get from now on. And that takes us to the variable displacement oil pump. That's been a point, I don't know has anybody heard of it? Has anybody dealt with it? All right, so in the past, a fixed oil pump has a set pressure per RPM. For example, if a driver's waiting at a long red light and he's idling, he or she is idling, you don't really need 40 PSI of oil pressure when you really only need 15 to not throw a rod, not spin a bearing. I know that goes against everything you've heard. Why would you purposely reduce oil pressure? But that's a parasitic load, just like your AC compressor, your alternator. It takes all those that little bit extra fuel to keep it running. So why would you want 40 or 60 PSI of oil pressure when 15 is plenty? So there is a solenoid valve on the side of the engine that's controlled by the ECM that sends a signal, and I will show you a picture in a minute, sends a signal that tells it when to actuate. And I will get in, like I said, I will show you some pictures in a minute. But now, at a red light, you can have your 15 PSI, for example, of oil pressure, and instead of full on. And then say maybe the driver's going down the road, steady load, level ground, steady throttle, at cruising speed. Again, did they really need, say, 60 pounds of oil pressure when 40 will do? So it has been designed to adjust oil pressure optimally to reduce that parasitic load. However, driver goes to pull a hill or requires engine brake function, it's going to ramp it up to full on. And the good side to this is if there is a malfunction of any kind, it defaults to full pressure. So if theoretically you went over and took side cutters and cut the sensor wires, it's going to default to full pressure. So no outside influence, full pressure. It takes outside influence, like from the solenoid from the ECM, to reduce the pressure. So it's a fail-safe built in. Having said that, I'm going to jump out of this PowerPoint slide real quick, and I'm going to show you pictures of an actual oil pump that was in testing in our powertrain facility in Hagerstown. This came off a test engine that after X amount of hours, they tore an engine down to inspect the entire engine, and this is the half of the oil pump. So it's a vane style system, very similar to if you've ever taken your 1/2-inch impact gun and opened it up because you had to do a rebuild kit on it. Same concept of the vanes, only you've got the rotor and you've got the housing, and you've got those vanes that pump the oil. And the other side of the housing, as you can see, this black part here can move. It's anchored here, and it can move back and forth in this area. That spring is keeping it pushed to where it's going to pump the backs. When the oil signal comes in, it pushes backwards and it readjusts the geometry basically of the area, of the volume area. And that's where it gets the pumping more or less. So if you don't have oil coming here, it's going to be full pressure. And then the last picture is simply both of them together. So as technicians, I know, we're analytical. We want to see things. Now you can see both of them together and see in your mind how they would bolt together and see how they fit. And it kind of makes sense. So this isn't some on-off pulse width modulated thing where you either have oil pressure or you don't. There's always oil pressure, it's just how much. So from there, we'll just jump on back to the PowerPoint. And before I go any further, because the design of the oil pump, the oil pan is different. So there's a jut out on it. So the pan is not backwards compatible. So for example, if you have a customer that says, hey, I've got a leaking oil pan, whatever, something, road debris dinged it, but I can still drive it for now. I'll bring it in a few days. Can you order my parts ahead of time? Your parts department needs to know that they need to go by the VIN, not, oh, we got an oil pan on the shelf, because they are now different. That's going to be a common theme you're going to see today about part numbers and going by the VIN, especially once you go through the electrical department, the electrical stations. VIN-specific parts is key, because there's a few changes. So we'll get into the fuel system here. We don't have an injector here today, but I don't think we really need one. I'm pretty sure everyone, that's in your wheelhouse. So the injectors are now F3 injectors, whereas the old ones were F2 injectors. The only visual difference you would see is the tip. You have 7 spray holes instead of 6, for the obvious reason that it's now a 7-wave piston instead of a 6-wave piston. They go hand in hand. They've got to line up and clock correctly. Internally, the needle control valve is now 1 millimeter instead of 2. It allows for less internal leakage and better needle control valve function. That alone was, I believe, 0.1% of fuel economy improvement, just the injector style. So it wasn't just making them more dependable, more robust, it actually improved fuel economy. Having said that, there's no other difference in the rail or the fuel lines, and they will bolt in the head. Going back to making sure you have the right part number, you can install an F3 injector in a Gen 2 turbo compound engine and vice versa. The heads are backwards compatible between these engines. So you don't want to make the mistake of, your first mistake is you installed the wrong injector, but the trim codes will program. So you're not going to know it till you fire it up and you have a fuel knock. So it's incredibly important that you get with your parts department and say, I need the correct injector, not based on somebody's memory of they know where it is on the shelf in the parts room. So making sure you have the right one. And from there, I believe we have covered everything on the fuel system. So we then move on to the piston assembly. Obviously, you've been around the wave piston, you understand the theory and how it works. Okay, because we did have a crew here from Export that they're jumping from 2004 emissions to current in one fell swoop. So yesterday I had to explain it from scratch. So you've been around it, you've seen it, that's good. So you now know that there are 7 waves and that the fuel is sprayed out and then turns the corner and distributes back. So obviously you can't install a 7-wave piston in a Gen 2 turbo compound, for example, and vice versa. So if you look at these right here, from your distance, you probably don't see anything different. But if you look really close, this is a 7-wave piston. The piston height is shorter. This is a shorter piston right here. This is taller. That's a bigger diameter wrist pin than that one. But overall, they're the same length. This is the same length. So that was accomplished because this is a longer connecting rod. If you go from center of hole to center of hole, this is a taller rod. So you'll never be able to put the wrong piston on the wrong connecting rod. The wrist pin dictates that. But you can assemble this and install it in the wrong engine, and you will bolt on ahead and it will rotate and it will try to fire up and run. But the software knows which injectors you're supposed to be firing and whatnot, and it's not going to run right, especially if you do a one-cylinder repair. So what was the reason for making this change? This has what's called a shorter compression height. It achieves the compression, the top dead setter to bottom dead setter effectively is different. So the reason for that is, if you can imagine this assembly, this is the piston and this is your connecting rod. At that part, that angle in the rotation where it's kicked out the furthest, the angle is steeper on the 6-wave. The way they redesigned it, the angle is further in. It's a less of an angle. The steeper angle puts a side load on the piston to the liner. So that angle, it's actually pushing against it, and that is friction and resistance that is now gone with this. It's not gone all the way, but instead of a lot of side force, it's reduced the side force on the liner walls in both directions. And because it's a smaller mass rotating, less vibration, quicker to rev up, that kind of thing. And the one last thing, we don't have rings on these pistons, but the top ring is different. If you look really close, you will see that the top piston ring, this groove is wider than that one. And it was designed mainly for less friction. It seals even better, but there's less friction on it. So that is the biggest reason why the change was. But again, you've got to know, if you've got a scenario where you're doing an engine repair and somebody else near you is doing an engine repair, and you've got a Gen 2 and they've got a Gen 3, don't mistake some parts, that kind of thing. So that's the biggest reason for those changes. And again, that resulted in better fuel economy, more power, reduced emissions, more complete burning in the combustion chamber. The wave piston, the way the injector nozzles are clocked so that the spray pattern comes down and hits the very middle and then ricochets back toward the middle. Amount of fuel and all that's the same, but if you have, this is a 6-wave piston. If you have a F3 injector installed by mistake, they won't line up all the way. And then your distribution of fuel isn't right. I always liken it to, everyone's done it. You have a spoon in your kitchen sink and the water hits it just right. Next thing you know, your face is wet. That's the way that fuel sprays here, and it turns the fuel around both corners and shoves it back to the middle. And if you have the wrong injector per piston, you're not going to get the lineup, and then you'll have a fuel knock, among other things. And the last major change, believe it or not, it wouldn't seem like it, is the engine module. Why is this an improvement? Because most notably, this went from 130 pins to 196. So it's expandable. So they don't need it all now, but let's just say, for example, in a few years, there's a Generation 4 turbo compound or something, and they decide they have to add 5 new sensors. There's room for it. Software will load it up and it'll run. It also has faster reaction. It's a global standard to improve the response times, and we meet that. We actually exceed it. So when you want your EGR system or your turbo, whatever, to respond more robustly, this has faster response times on it. But there's also more memory. So in the past, I know, for example, when they added the EAT health check, other tests went away because there wasn't room in the memory for all of it. There's room for all of that plus more for future expansion. So my dealings were, engine modules always had this window of time where there was compatibility. You had to have a certain part number module for a certain era of emissions. Now, hopefully, this will broaden that window. Now, for a long time, this module, can be used, one part number can be used to serve more engine ranges. So that was the biggest reason there why we felt like that was worth speaking to. Any questions so far?